right, so this first screen that you're looking at, you're going to solve the equations. Okay, we talked about solving equations multiple times, so go ahead and pause the video and y'all work 1 through 6. Okay, here are the answers. X would equal -1, 3, y would equal 3 on 2, x would equal 6 on 3, 4, x equals -2, 5, a equals -20, and finally 6, x equals 7. Okay. Hopefully you got all of those right. All right, write and solve the equation to find the number. Okay, we worked on this a little bit, but we were struggling, so I'm going to kind of go through these. All right, the difference means to subtract. Okay, so the word the difference means to subtract, and we look for the word and. The difference and. So that tells us where our subtraction symbol is going to go. Okay, then we have twice a number here. Twice a number, we could say is 2x or 2n, whatever variable you want to put in there. It doesn't give us one here. Is our equals word, and then 15 is our number. So that would be 2x minus 9 equals 15. And then you would solve it. Okay, the sum of 4 times a number and 1 is -7. Sum tells us to add. We look for the word and. So that's where our plus sign is going to go. 4 times a number, like 4x, is equals -7. So we put that together and we have 4x plus 1 equals -7. All right, 3 times the difference of a number and 8 is 12. Okay, so we're going to multiply the entire difference by 3. So we're saying 3 times some other thing. Difference means to subtract. The word and tells us where our subtraction symbol goes. We have a number, so x, and 8 is our equals. So 3 times x minus 8 equals 12. And finally, the quotient of 4 minus a number and -9 is 2. Quotient tells us to divide. We look for the and that's our division symbol. 4 minus a number, so 4 subtract x, and -9 is equals 2. So 4 minus x divided by -9 equals 2. Okay, then you want to go ahead and solve them and write your answers out to the side. Okay, I would like to remind you that you can use your calculator to do this. Okay, let me clear my screen. All right, and we had, what was one of our problems? We had 4 minus x divided by -9 equals 2. So in my calculator, I would press menu, number 3 for algebra, 1 for numerical solver, and then I would type my equation, which was 4 minus x divided by -9 equals 2. So we need a fraction bar, so we're going to bring fraction up, and that's highlighted, so we just hit enter. 4 minus x divided by -9 equals 2. Whoops, let me go back. I did something silly there. I didn't bring my out. So equals 2. Then we put a comma. And we wanted to find out what x is, so we now put an x, come outside the parentheses, and we hit enter. And that tells us that x would be 22. Okay. So you can do the remainder of those on your own. So x equals 22. All right, moving on. Okay, work with a partner. Well, I'm kind of your partner. The National Collegiate Athletic Association, or the NCAA, uses the following formula to rank the passing efficiencies P of quarterbacks. Okay, it's very complex. Okay, and here's a description of all the variables, what they mean, what they stand for, and then this is how the attempts can be grouped. So a quarterback throws so many passes. Sometimes they're completed. That means the other guy catches it. Sometimes they're intercepted, which means the other team caught it. And sometimes they're incomplete. Nobody caught it. Okay? When they're completed, they calculate the number of touchdowns and not touchdowns from those completed passes. Okay, so we want to determine whether the following were true, and we explain our reasoning. Okay, so one way this might go is we have T has to be less than C. So T was the passes resulting in a touchdown, should be less than C, which is our completed passes. Well, that makes sense because completed passes are broken into two groups, touchdown and not touchdown. So we would expect the number of touchdowns to be less than the number of completed passes. Okay, so I would say that is true. C plus N, so the completeds plus the intercepted, so these two numbers right here, would be less than or equal to the number of attempts. Okay, that too makes sense to me. I'm going to say that one's true because if we have three different categories, so if we had numbers in all three, these two added together would be less than the number of attempts, right? Because we'd still have incomplete passes. And if there were no incomplete passes, if there were just intercepted passes and completed passes, then C plus N would equal A. All right, so N is less than A. N is our intercepted passes would be less than our A, which is our attempts. Again, similar reasoning to C plus N being less than or equal to A, we would expect our intercepteds to be less than our attempts. Now, I suppose it's possible to have a quarterback who's just really, really bad, and we could also say that that would be equal to there, but I really think they would have taken him out and put in a new quarterback at that point if that was the case. So, and so this is one way we could explain a reasoning. There are other things you might be thinking about. Y'all might be football experts, and you may have more to weigh in on this. Okay, let's see. A minus C would be greater than M. So the attempts minus the completeds would be greater than the incompletes. Attempts were 10, and the completed were 2. That would mean that at most the incompletes here would be 8, right? So that would give us 10 minus 2 and 8. So 10 take away 2, 8 would be equal to 8, so that's true. All right. Let's see, is there any other way we could do it? What if we had 8 completes and 2 incompletes? Let's try that. 10 take away 8 would be 2, which would be 2 again. All right. So I think with that, without having any intercepted, so let's change the numbers up one more time and see what happens when we have. Okay, when we calculate in the intercepted. Let's see if that changes at all. All right. So if we say there were 10 attempts, we had, say, 6 and 1 and 3, okay, because 6 plus 1 is 7, plus 3 more makes 10. All right, so if we put those numbers in, we have 10 minus 6, and then the M was 3. So 10 take away 6 is 4. 4 is greater than or equal to 3. Okay, so it looks like it's true. Again, I'm going to leave it to my football gurus to come up with any other arguments that I might have missed. All right. We're going to skip this because doing a video on this, there's just way too many possibilities, and it would just take us too long to get through that. So we're going to skip that for now. Okay, we want to talk about core concepts or big ideas is the addition property of inequality. When we had equations, so equalities, we were allowed to add the same thing to both sides. Well, that's what this says. We can add the same number to both sides of our inequality, and the inequality is still true. All right, and that's what they're showing you some explanations there. So what does that mean for us? So if I wanted to solve this inequality, all right, what would I need to do? Well, first I suggest you write down the inequality. And because we have minus 6 and we were trying to get x by itself, right, when we solve, we're going to add 6 to both sides. And when we do that, we find out that x is greater than or equal to negative 4. So the solution would be x is greater than or equal to negative 4. So a graph of that would be, we have our colored in circle at negative 4 because of the equals to. The numbers to the right are where the greater, okay? And so this would be our graph. Okay? Another thing we talked about is you can actually put some numbers to it. Negative 5 is not greater than negative 4, so we wouldn't shade in this direction. 0 is greater than negative 4, so we could put 0 in this direction. All right. So now here's some for you to try. So if y'all would pause the video and try these 3 inequalities to solve them and graph them. Okay, so after you've paused the video, let's check your work. Number 1, you should have gotten that b is greater than negative 7 because you added 2 to both sides, and the graph would have looked like this. Okay. For number 2, you would have added 3 to both sides and found out that m is less than or equal to 8, and your graph would look something like this. And finally, you would have added 1/4 to both sides on this one and found out that y is less than 1/2, and your graph would look something like this. Okay, the same thing that works for addition works for subtraction. We can subtract the same number from both sides. So here we have y plus 8 is less than or equal to 5, so we would want to subtract 8 from both sides. And when we do that, we find out that y is less than or equal to negative 3. That's our solution. Okay. And then we want to graph it. So we put our colored in circle at negative 3, and we shade to the left because y is less than negative 3. Okay, so if we're looking at b, we write down our inequality. Here the 1.4 is keeping m from being by itself. So we would subtract 1.4 from both sides. Okay, then we would find out that negative 9.4 is less than m. So our solution, notice how we switched it around. We wrote it back this way. M is greater than negative 9.4. So we put the circle at negative 9.4 because it's not included, because we don't have the line underneath. And then we shade to the right because that's where the numbers are greater. All right, here's some for you to practice. Pause the video, take about 5 minutes, and see if you can solve these. Okay, so back to work. We would have subtracted 5 from both sides and found that k is less than or equal to negative 8, and your graph should look something like that. For number 5, you would have subtracted 1/6 from both sides and found that z is greater than or equal to 2/3. And then finally, you would subtract 0.7 from both sides and find out that p is greater than negative 3, and your graph would look like this. Okay. All right, now a word problem, some of our favorite things. A circuit overloads at 1800 watts of electricity. You plug a microwave in that uses 1100 watts. Okay? Write and solve an inequality that represents how many watts you can add to the circuit without overloading the circuit. In addition to the microwave oven, which of the following appliances can you plug into the circuit at the same time? Okay, so the first thing you want to do is try and understand the problem. You know that the microwave oven uses 1100 watts out of a possible 1800. You are asked to write and solve an inequality that represents how many watts you can add without overloading the circuit. So in addition to the 1100, what can you do? Okay. All right. So one thing you can do is use a verbal model to write an inequality. Then solve the inequality and identify other appliances that you can plug into the circuit. So how would that look? Okay. We have watts used by microwave oven plus the additional watts should be less than the overload. Okay. If we let W be the additional watts, then we can write 1100 was what the oven uses. W is the additional watts, and it has to be less than 1800, which is what will overload the circuit. You notice it's less than, not less than or equal to, because at 1800 the circuit's going to blow. Okay, so there's our inequality. And then we solve the inequality using subtraction property. We're going to subtract 1100 from both sides, and we find out that W would need to be less than 700. Okay, so using that information, we can see up here that we could plug in the clock radio and the blender, but not the hot plate and not the toaster. So the microwave oven uses only 1,000 watts. Okay, so that's new to this problem. So we're going to start with 1,000 watts plus additional watts again, which was W, still needs to be less than 1,800. Does this allow you to have both the microwave oven and the toaster plugged in? Well, let's see. Right now we know that we've used up 1,000 for the microwave oven. So if we solve our inequality by subtracting 1,000 from both sides, then W would have to be less than 800. Okay, so we need to find out how much did the toaster oven use. So we go back to our chart. The toaster oven used 800. Okay, so since the toaster oven used exactly 800, right, so W would have to equal 800. If we substitute that in, that would be saying that 800 is less than 800. Well, I think we all know that's not true, so no, we cannot plug in the toaster oven.